Hi, and welcome to week 8 of our online course here. So I'm just coming back from a conference, a computer science education conference, where I was telling everyone who was willing to listen about how the Udacity course works and how we're doing this online course. And what everyone actually thought was most exciting was the homeworks. 3 homeworks a week, a draft and a final, all graded by a state-of-the-art autograder. That was something that not everyone there was familiar with, and they really liked it. The other thing that they like, I'll show you that later. There's one thing that I want to say before we get into the subject of week 8 here, and that is in the quiz that reflects back on chapter 5. In order to do well on the quiz, there's probably one thing you want to look at before that, and that is here that special topic on De Morgan's law. So De Morgan's law says if you want to negate an and, then you negate the individual parts and you join them by an or. And it also says that it is not true that some people won't be confused by this code. In general, humans have a hard time with double negation and negating ands and so on. So remember, there was a discussion on Piazza where someone said that I would probably say, yes, I would like to have pizza or pasta. And what's the opposite of that is that, no, I don't like pizza and I don't like pasta. So the opposite of an or is an and similarly the opposite of an and is an or. With the negations, of course, then moved inside. So read through this thing. I could say it 3 more times and it wouldn't make it any clearer. But if you think it through with your own examples, then you'll get the hang of it. And be careful to use that on that last quiz on chapter 5. So now we are on to chapter 6 and to loops. And that's probably the single most useful and exciting programming concept that you can learn, because the loops help you with automating repetition. And automating repetition is my favorite part. I hate doing the same thing over and over. You should have seen me cursing those 100 USB sticks that I had to insert one at a time, because I could see no way of automating that. But in general, the reason that the computer can go through stuff with blazing speed is that it'll automate repeating tasks, and you just have to tell it what to do each time. So that's broken up into 3 weeks at Udacity and at this course, because while the beginnings are pretty easy, it's not that hard to, as you'll see in the first example, to apply an interest rate a bunch of times. It does get more intricate later on, and that's because, of course, the program is on autopilot once you tell it to do the repetitions, and you have to very, very carefully schedule the repetitions to do the right stuff at the right time. And so there's several parts to learning about that, and the first one is to actually just learn how the mechanism works. And that's not as easy as it sounds, and so I've come up with this nifty way of demonstrating that, and that was the other thing that I went to this conference to show off. So I've given you an example here for these walkthroughs, and so you really want to try that. What you do is you click on the start button, and then the rest should be kind of self-explanatory. So it starts up setting up the problem, and once it comes to a rest, then it says, please click on the next line. And so now you should, from your understanding of the while loop is, which you'll be getting after the first lecture, you should now figure out, does it go to the first line inside the loop, or does it actually go out? Well, in this case, it goes here, so you click here, and then it asks, please enter the new value of first. So you see over here there's a blank spot. Now let's see. Rest is the string tooth. From 0 to 1, that's the first letter, that's the T. Type it in, hit enter, and then it asks you the next question. So go through this whole thing, and then you'll see what this loop does. It does something useful, and actually I'll tell you down here what it does, but it's a good idea to first just run through it without any preconceived opinion, and then from the behavior figure out what it does. I'll be giving you a bunch more of these little things where you can practice just tracing through loops. Tracing is important, and nowhere is it more important than with loops. So then we have another fun assignment here, where you get to loop through the pixels in an image. So looping through the strings of through the characters of a string is like a bread and butter thing. It's useful, it's easy to test, but it does get a little dull at times, and I like to toss in these pictures to liven it up. So I think you'll enjoy those exercises, and there's a lot of good stuff in the Udacity lectures that leads you up to it. As always, when you have questions, and you're bound to have many questions about the complexities of this topic, really put them on Piazza. Put in any code that you have on Piazza. I don't care if it's good or bad. I don't care if it gives away any secrets. The more you put on there, the better. Just bring it on, and then we'll all help you out with your problems. I don't want to sound alarmist, but many people, when they first read through this section, this chapter on loops, they say, well, that's all easy because the syntactical constructs are easy. But what's hard about it is when you have a specific problem, like the problem here with those pixels, or the problem here where you have to find repeated letters and eliminating them. It's not at all trivial how one should arrange one's statements, and there's absolutely no recipe to do it. One really has to do a lot of examples and just gain experience on how to do that scheduling of each of the individual tasks, so that when they run at full speed, that everything just happens right at the right moment. So bring it on, put all of your problems on Piazza. Anything that you have started and it doesn't work out, just put the code on there, and then we'll look at it together.